Okay, very briefly, we have two coaxial cylindrical shells. We can think of a voltage, one terminal being attached to the outer, another to the inner shell, so that we can create a voltage V, or at least to transfer charge from one cylinder to the other, so that we're separating charge as we usually do. By use of a Gaussian surface, we can determine that the field at any point between these cylinders is 2 pi kq over LA, and we have the details of applying Gaussian surfaces. Okay, we create a Gaussian surface in between at distance A, and we get this electric field. Plugging the numbers for the problem, the 4 microcoulomb charge, the 7 meter radius, and the value of K, we end up with electric field expression 3 times, well, I'm not going to read it to you. Here's the electric field expression. If we substitute A equals 4 centimeters, the radius of the inner cylinder, that comes out approximately, and of course I'm doing mental approximation, so I could be off by a few percent. Be off by a lot more than that, so make sure you check my numbers. But I think we get 7.5 times 10 to the 5th newtons per coulomb, within a plus or minus a few percent. If we then multiply that electric field, imagine moving from the inner to the outer sphere along a radial line. The electric field and the displacement vector delta S are parallel to each other, so their dot product is just going to be the product of the average electric field times delta S. The average electric field, well, this is the electric field here. It's going to get a little less out here, but just using that approximation, we get this result, 1.5 times 10 to the 3rd joules per coulomb. We could integrate this expression from the inner to the outer radius. We get this integral, and evaluating the integral, we confirm this estimate if this expression here turns out to have been right. There was a mistake on the original. I had 4 here because I just doubled the field of the inner, because that's what you do on a parallel plate capacitor, but the field or the charge on the outer cylinder has no effect on the electric field at points inside of it. Okay, that's a fairly obvious argument, so you should understand that.